So, welcome to the second and now annual PyCon Sweden. Yeah, I think, yeah. Anyone can do a conference once, now we're doing it twice. We're official. I'd like to give a very special thanks to all of our sponsors, especially the gold sponsors, Findic and Pluralsight, and a thanks to the PSF, Python Software Foundation, who sponsor the recording, so that we can get professional videos up. Without the sponsors, we would not have a conference at all, or you would all have to put a zero at the price at the end of the price of your ticket. So I'd like a round of applause for the sponsors as well. Thank you. Some details. We will have 2 tracks and 2 rooms for most of these 2 days. This is the main room named Olympus in the schedule. And the other room, the panorama, is if you go all way down the hallway, past the hotel reception, and then you go downstairs. There should be signs by now. And that's the panorama room. So you can find it. The lunch, which is served for everybody who's got a blue stripe on their badge, will be downstairs from the reception. It should be pretty easy to find because all of the people will be going there. There is a Wi-Fi called H-Honors, which is open and may or may not break when you all connect to it. You should use this Wi-Fi to tweet and just blanket Twitter with tweets. The hashtag is PyCon SE, and the official PyCon SE account is @PyCon SE. The staff all have these beautiful t-shirts. So if you need help with anything, just ask anyone with the gray PyCon t-shirt. There will be, at lunch, you will receive a drink ticket for tonight, which is redeemable for a free drink in the bar, which is in the far end of the building. So don't forget to pick that up when you go to lunch. And on the subject of free alcohol, don't also forget that we do have a code of conduct. So if you haven't read it, maybe you want to, and just generally be excellent to each other. But on the other hand, do have fun, talk to strangers, sit next to strangers at lunch. I want everybody to sit next to people you don't know and talk to new people. If you want to talk to a lot of people at the same time, you can always sign up for a lightning talk. There is a big notepad outside, and it's first come, first served. Just jot down your name and what you're going to talk about. And we have the lightning talk sessions at the end of the day. And if you do sign up for a lightning talk, make sure that you're here before the lightning talk session starts, because we are not going to wait for you. If you miss your chance, well, you can go to the end of the queue and maybe have your lightning talk. I would also like to give a very special thanks to all of our speakers and especially the invited keynotes. I think we have an amazing program today and tomorrow, and I think it's going to be absolutely brilliant. For all of the speakers, I would like you to go after the keynote, go directly to the registration desk and find your session chair, just so we can make sure that we have the adapters we need and try out your laptops or find out if you need to borrow a laptop for your presentation and so on. So all of the speakers after the keynote, go to the registration desk and find your session chair. And that is all, actually. I would like to leave this stage for our first keynote. Ian Ozswald.
Thank you very much. Frederick, I've lost my screen. Morning, everyone. Perfect. So good morning, everyone. My name is Ozswald. I'm over from London. So on Frederick's note about meeting new people, I don't know any of you. I don't know Stockholm. I don't know Sweden. So come and talk to me. That'll be lovely during the day. So I'm going to be talking on data science deployed. So I'm a data scientist. I've been working in this industry for 15 years in the UK. I run a company, Model Insight, an agency in London specializing in using data science for companies. I'm going to be trying to convince you around the benefits of data science and trying to bring you over to my side. So I'm also an O'Reilly author. So last year I published High Performance Python. I've spent 5 years talking about that at conferences, things like PyCons in the US and EuroPython and EuroSciPy, so around Europe and the US. And I got bored of talking about it. I kept on running different tutorials, different talks, writing blog articles. So I got to wrap that up in a book. So if separate to data science, you're interested in high performance problems, come and talk to me, because I love to talk about this too. I also co-run the PyData London group. So PyData London is a monthly meeting of data scientists. We started a year ago with a conference exactly the same size as all of you here. So we had about 200-ish people in a room. That went so well that we started a meetup, and that went from 60 people a month. That's around 150 a couple of months ago. And then our meeting just last week in a hedge fund, we had 220 people in the room. So it's a monthly meetup that's now bigger than the first conference we ran. And we're planning our second conference now. So at least in London, the world of data science is growing up really quickly. So it's growing quickly. Many of you have heard of it. You may not know what it all is, what the reason for it is. So as I say, I'm going to try and convince you to get involved. So my goal here is to try to convince you that we want to mix data-focused people and engineers so we can deliver new and high-value products, particularly in the Python world. The goal will be to go to make products that go faster than humans and are more accurate than humans and are more reproducible. So rather than having a human's gut instinct driving decisions, which is a perfectly reasonable thing to do, it's not terribly scalable, it's not reproducible, we can get tired, we can be distracted, we can be hungover. And so it's hard to get a consistent level of service or a consistent level of decision making. And the goal is that we can use machines to make this go faster and more reliably, and then more scalably as a result. And yes, so I want you to become a data scientist. If you want to refute that idea and you want to tell me that there's no good reason for you to become a data scientist, then come and tell me as well. So who is a data scientist? There's a number of glib descriptions as to what makes a data scientist. For me, really, it's the second one. So a data scientist is an engineer who knows more statistics than their colleagues, that's kind of me, or a statistician or a machine learner who knows more engineering than their colleagues. Really, I think one of the big distinctions with the data scientist is this is someone who knows how to take a problem definition, work in a researchy way through it, trying to figure out a solution. So it's kind of an engineering mindset, figuring a way through, applying lots of analytical and research tools and maybe cutting-edge research, maybe technology from 40 years ago, and then wrapping it up. So not just delivering a pile of scripts that might work on one person's machine, but wrapping it up into an engineered solution that you can deploy so it has business value. So to me, that's the key distinction about a data scientist. Now, one of the key questions would be, why is data science in the news now? It's been talked about for maybe 5 years, kind of at the same time as big data. And I think there are a couple of trends behind this. The main one, so this chart measures internet penetration by number of users, and I'm concerned here with the developed world, so the blue line, and I'm not worried about the other two lines. So in the late 90s, when I was doing my undergrad and then doing my master's degree, internet penetration was very low. So I remember using FTP and Gopher at the beginning, and then using NCSA's first Mosaic on a late 486 or maybe a Pentium. And that would have been the start of that blue chart, so the 11% penetration. If you were a business and you put your service or product or whatever you had online, with the blink tag maybe and black and white text, and it was a really rubbish website, but you put it online, then you had access to 10% more people than your competitors had, so it's easy. And then over that first decade, as long as you put your service online in any shape or form, you applied some SEO, you made it somewhat discoverable, you mailed the editor of Wired magazine and had yourself covered, you got great exposure, so your business could grow without doing anything particularly clever. It was basically a new catalogue that you were using to a new audience. So that gets you through from the mid-90s to sort of early 2000s. Somewhere around 2005, we see the advent of the smartphones. And then a bunch of people get smartphones, and so all of a sudden websites don't work so well on small screen devices. They're working great on desktops, then they were working okay on laptops, and now you've got these tiny devices. But as long as a website was updated to be reactive in some shape or form and to render on a mobile device, then you had a whole new world of customers. All of a sudden, my mother, who's never had a laptop, gets a smartphone. So she is part of this next generation of people who have a different expectation about the world, but want to access services and products. They don't care about data, they don't care about customization, but just the advent of the mobile phone gets them online. Then we get up somewhere around 2010, and we have pretty high penetration, going on 70%. And that's when not only when businesses are online and serving up their content to laptops and desktops and mobile phones, but all their competitors are online as well, because everyone's figured out the internet's a good thing by now. So everyone's online, everyone's serving up content, everyone's consuming it online, and now there are a few differentiators. And I think one of the driving forces for data science is simply the fact that the easiest way to offer a better service than your competitors is to use your data for some kind of natural advantage. And for any company that's not using their data, they're going to begin to fall behind. And that's going to be a bad idea. So to give that, make that a bit more concrete, there are two ideas behind this. One is the move from a mass production economy, so the shipping of Chinese mass-produced physical units of televisions or whatever, to a notion of massively customized services. So I go to Amazon, I see all of the world's products laid out in front of me, just as any of you do, but we each have a very different experience. We'll see different product recommendations, possibly different reviews, possibly different pricing strategies being applied to us. And even if we're both first-time customers, as soon as we click one different thing each, due to the wealth of data Amazon has about what those clicks might mean, it'll start to serve up different content and different customizations. So any website that is doing a really good job of exploiting its data is giving a customized service to every single user visiting, even the ones that it knows almost nothing about. And then we have this notion of a data moat. So here, if you've gathered private data, so not open data, not data that you're sharing with other companies, not data from, say, a government, but your own data that you've gathered, if you can exploit that, then you have a natural advantage. I can tell you that with my current employer, we're using machine learning techniques like logistic regression, linear regressions, random forest, Gaussian processes. It doesn't really matter that I tell you what algorithms we're using, because with those algorithms, you get a vague idea as to what the quality of the data science team might be and what kind of problems we might be solving. But I can also tell you that I've got 1.5 years worth of work with a team working on private data sets, and you can't copy that. So I know that we've got a really strong advantage in the company there just because of the data that we've got, not the algorithms that we're using. So Spotify, obviously a music recommendation service. The more time you spend in Spotify, the better the recommendations for the music that you get are. And if a new user comes along where Spotify knows nothing about that user, as soon as they listen to a track and make a selection in the site, They've got very good evidence as to what people like this kind of person already listen to, so they can make better recommendations. So it's obvious that you would use Spotify. If Ozswaldify, the new music recommendation service, were to appear, and I know nothing about the listening habits of any of you lot, you would tell me pretty quickly that my recommendations are rubbish. And that's because I don't know what kind of music you prefer to listen to. So naturally, you would stay inside Spotify. King, the online gaming service, they use their data in a different way, particularly for things like churn analysis. So they can see when customers are coming in, when they're playing games, what kind of upgrades at different times cause customers to get more involved in a game or to switch off and leave a game. And if they're leaving a game, how do you reactivate a customer? So how do you bring them back in the most effective way so that you can monetize them better? And it's only because of the wealth of data they've got that that's possible. And Google Maps and Apple Maps, please put up your hand if you have an Apple iPhone. Okay, keep your hand up if you use primarily Google Maps as your navigation tool. Okay, and then switch your hands if you use Apple Maps as your navigation tool. Right. So there's a couple of you. You're brave. It's reasonably well known. I mean, this is Birmingham in the UK. The coverage in Apple Maps is rubbish. So technologically, the service is pretty similar between the two apps, but the data that Apple has is just inferior to the data that Google has. They've spent a lot of time improving that data set. And Elevate at the bottom there, this is my current employer. So I've been working with these guys for about a year and a half. If you'd have asked me 2 years ago would I want to be working with a recruitment firm, I would have said, no, they're recruitment firms. They're full of horrible people. It turns out these guys figured out that they were going to be, at some point, someone in the industry was going to automate recruitment. So they're contract recruiters. They wanted to not be put out of work, so they chose to automate themselves out of a job so they could exit on that business. So here's the challenge. You're an HR department. You've been told we need to hire a designer. These are the kind of skills the designer needs. This is what we're going to pay. This is when we need them and where we need them. Please find the best person, and we want them next week to start. So you log into Elevate, you put in your requirements, it brings up this display with like a Gantt chart of experience and skills. And from this you think, okay, great, the guys at the top, they all look pretty sensible for this job. The magic here is that we don't ask, if you sign up as a contractor, we don't ask you to type up your CV in the right format for our site. We just take any old CV that comes through any recruitment site. You click on the job, we look at the CV, we understand it, we pull it apart. We pull out the companies you work for, the time frames you're there, the skills that you've got, and we can look at things like differences. It's mainly for, say, contract recruitment into banks, so C# is a big thing. Maybe you've got C# on your CV, but the customer's typed in that they want .NET experience. So we know that C# and .NET are very similar skills. We know that Python and .NET aren't particularly similar, but if I've got ASP.NET and scripting on my CV, and the customer asks for C# and Python, we know that those things will go together. So here we're building up this data moat around the recruitment space, simply to take humans out of the loop. So when I've been describing data science to people, I've been asked, how is this different to regular engineering? So here's a short view into a day in my life. I spend most of my time thinking about how do I turn the data we've got into more business value. So I don't focus my time, I've done this in the past, but now I don't focus my time on how do I improve the algorithms, how do I improve a deployment strategy, how do I better document our service. I think more in terms of the data. So particularly about its quality. Low quality data is very bad, we can't go very far with it. We need high quality data. And when I've got high quality data, how can I better predict or classify something that's valuable to the business? And then I have to do some work on deploying and testing and documentation, but that's definitely a small part of my time rather than a larger part. So I hope I'm giving you an idea that, that you want to start thinking about working on a first project. So you need to be thinking about working on a high-value project that's relatively easy, so something that's achievable. It's easy to do think about a really cool sounding project and then forget about the business value question behind it. So you want a high value project for the business. Probably you're going to share insight. Maybe you're going to augment some data. Maybe you'll automate a process. Or maybe you'll be predicting the future. And I'll give you some examples of each of these. And it's very important to remember that you have to deliver value at the end of day one and then at the end of day two. It's ridiculously easy to get into a new problem, see complexity at every level, and then dive into it, and disappear for days or weeks or months down some rabbit hole without sharing knowledge and results back with your team. So, and this is particularly true of academics coming into the field, I've discovered. They're very used to the idea of working for 3 months before reporting back a new level of result, which is a perfectly reasonable thing to do when you've got a 1-year grant or a several-year grant. When you've got a boss who's looking for reasons to kill the project after 1 week, you can't do that. So you have to think about delivering value and convincing people that the project is working every day and every week. So here's a simple example of insight. Did anyone take part in the #TalkPay tweet out 2 weeks ago? It was an American thing. I don't think it really got very far in Europe. So a group in the US decided that it's unfair that regular folk have no insight into what salaries look like for everybody. And so in a mass democratized movement, if everyone tweeted their salary with the #TalkPay tag, we could learn what everyone's salaries are for different kinds of jobs. So it's a very interesting in very capitalist America, this notion of sharing everyone's salary in a very public fashion. So there were some tens of thousands of tweets posted out on a Friday 2 weeks ago. One chap, Echen, grabbed them and processed about 1,000 of them and put them into a CSV file. And then many people said, this is amazing, there's great data in here. If only someone could draw a graph of it. And nobody even drew a graph of it. So I grabbed the data and spent an hour. This is using pandas, which I'll mention later, and matplotlib, so some of the very standard tools to make a histogram of annual salaries and the number of people in those roles. And you can see there's kind of a weight of evidence somewhere around the sort of $40,000 to $80,000 salary bracket for people who tweeted their salaries. But we don't get much out of that. If I search for software engineers, then we see a big bulk around, say, $80,000, another around $120,000, so that kind of seems reasonable in big cities. Another one around $150,000, that's kind of interesting. $200,000 and $250,000, so we see some interesting gaps and spacings turning up. And actually this chart carries on to $1.1 million over here, with only 9 people going out there, but it distorts the chart, so I cut those bits off. Now, this, again, might not tell you a lot. You kind of expect software engineers to be earning a lot. But if you're looking into your data, you're trying to find interesting and surprising things. So if I pull out teachers, we find the median around $30,000 to $40,000. This is, well, for a start, you don't want this to be the case. Teaching should not be so massively undervalued that you earn 4 times more by going into software engineering. The fact that anyone put out their salary at $20,000 is pretty amazing regardless. So it's not very difficult at all to pull your data apart and to get a little bit of insight into what you've got and hopefully teach your colleagues something new about your data. So as I say, this took about an hour using matplotlib. Let's say now that you've got some binary data and you need to extract some data from it to do something, just to start graphing it perhaps. So you've got 10,000 PDFs and you're asked to copy-paste some sections of text out of there to do something with it. Or even worse, you've got PNGs, 10,000 scans, and you're asked to extract the tables of numbers and summarize them. How hard can it be? It's going to be awful. You'll be sitting there typing for weeks. So how can we scale that kind of data extraction? The Techstract project is a nice Python project. It wraps up all of those extractors on the right-hand side. So that's a number of open source tools, including extractors for Microsoft Word, Excel, PowerPoint. Using optical character recognition, you can pull data out of scans. There's speech to text. Oh, yeah, a whole pile. They're very useful, and there's a nice, easy interface there. And Apache's Tika, which is a Java tool, has even more extractors. It's a Java tool, so it's a bit harder to use, but it is quite easy to link into it. And in the recruitment company, we use Sovereign. So this is a PDF CV extractor, which knows about the format of CVs. So it knows not just where the words are, which is easy, but also which words are company words, which words are date words, which words are descriptions containing skills. So it pulls out higher level markup. So never be afraid to look for a commercial tool that wraps up a higher level part of your problem. And you want to be thinking on pipelines of transforms, so not one Uber tool that does everything in one pass, but a pass that extracts some data, a pass that cleans it up, and a pass that processes it. And to give you an unusual example of a project I've worked on, so here for the Royal Botanic Gardens in the UK, we made an iPhone app that talked to a server. You would take a photograph of a Latin plant label, and then it would be sent to the server, and then using Tesseract for optical character recognition, we would extract the text, clean it up in a number of passes, and then match it to Wikipedia data, and then you could present the Wikipedia data. So it's using a plant label as if it was a QR code, but without requiring a relabeling of 10,000 plant labels in the Botanic Gardens. And the Python side of that was on the order of tens of lines of code. So the next step on from there will be augmenting data, so taking raw data that you've got. You could graph it, you can chart it, you can do some recognition, you can do some searching, but you need to add another layer of value on top. Typically, this is a human-level process, but it turns out with some really good advances in AI over the last 15, 20 years, we can do things like identify people, places, and brands. So that's named entity recognition. So that's identifying a person who is mentioned in relation to a place in the world, maybe the company they work for, and everyone knows that sentiment analysis exists. Most of us know that generally in an automated fashion, it's pretty ropey. It's quite easy to confuse it. There are lots of simple techniques that don't take advantage of a human-level structure in the language. But there are some good tools out there, and Alchemy API, that's a commercial API. I use it for commercial projects. It's really good. They generally understand sentiment and brands, at least American brands, and worldwide locations and people. And so using a tool like DataSift that lets you extract social data, so Facebook data is a massive feed, and maybe NLTK, that's a Python library, the natural language toolkit. You can start to build the primitives up to customize your own service, or you go to a third-party service. As long as you bear in mind things like the context sensitivity required around some of these questions. If I've written a review and I say, I was terrified, for a product, maybe a car, that's a pretty bad thing. But for a movie, a scary movie, it's a great thing. So you've got to think about the context that you're working with and make sure the tool that you're using is customized to that particular domain. But if you can just do those kind of simple things, then here you have a social media tweet analysis, minute-by-minute discussions for one of the recent election debates in the UK. And even though it's just a volume of mentions of certain specific people, it ends up bringing in insight around the level of discussion and where the electorate may be going. So it's quite easy to put these things together if you use just a simple augmenting tool. Now, image work is a lot harder. 10 years ago, most people weren't working with images. The data was just too complicated and the algorithm's not working very well. Now we know that deep learning is working really well. There's a talk later today, I think, on deep learning. And it makes working with image data sets a reasonably tractable problem now. So there's a company that they list, they're a fashion recommender in London. They used to be our host for the PyData London events. Their biggest problem is they recommend fashion in a feed. So if they recommend a set of earrings, they say this is a set of earrings that you should buy based on your past browsing history, based on their data moat. If their next recommendation was, and here's another set of earrings that you should buy, we think you'd really like these, and they're the same sets of earrings from different retailers, but the same underlying product, you would think their quality of service was bad. It turns out that they've got something like 10,000 dresses marked simply red Prada dress, with no other codes behind them. So there's no universal product codes, there's no rich description, there's no way to identify from text whether these dresses are the same or different. All they've got are the images, so they use image analysis to do things like check for duplicates, so duplicate earrings, duplicate bags, so they can then give you one recommendation rather than more than one. In the Scikit image project, so that's one of the Python scientific packages, there's a nice selection of image manipulation tools, including looking for similarities between images, which respects distortion, rotation, and inversion. And if you want to go to the next level up, then the granddaddy project there is OpenCV. It has a strong robotics background. And so with OpenCV, you can do everything in Scikit image via the Python bridge into the C++ world, and a whole lot more, including good face detection, people detection, car detection, tracking moving objects, and a whole world more. So now we get onto the idea of machine learning. So there are two areas here, predicting the unknown and classification. So for predicting the unknown, forecasting the future and filling in blanks, so taking some data that you have and pulling some kind of relationship out of it. So demand prediction, seeing how much something is going to sell. Can we tell the life expectancy of a person given their genetic factors, their diet, can we predict their longevity, say for insurance, and price estimation? So scikit-learn will be one of the most likely tools that you turn to. This is the machine learning library in the Python world. We've got a set of options, but this has become the de facto standard. Inside Elevate, we're using this for price prediction for both pricing of a job. So if a client puts in a job with a certain set of skills, they want 3 years worth of Microsoft C# and whatever else they need, and we can say, well, given the contractors on the market, you would expect to price this job in a certain way. And then also, if you upload your CV, we can say, well, given your skill set and your historical development of skills over time, we can tell you that if you're working in London, you would expect to earn this kind of range of money. And that's taking hundreds of thousands of CVs and then building up a picture of what that pricing curve looks like for each of those skills. So to try and give you a picture behind that, for this project we were looking at predicting the final sale price of houses in the UK. So all the blue dots, these are records of final sales with government open data, which are matched against price against metre squared, so the size of a property. So you can see that general trend there, that the larger the property, the more the price goes up. And in some areas, price goes up very steeply. And we don't really know what's driving those trends. So the green dots here, that's down in Brighton on the south coast of the UK where I used to live, a lovely hippie-friendly city. There's a certain base price, so it's not by any means the cheapest place in the UK. There's a base price well above the bottom line, and then the price increase is kind of at a shallow line. If we look at the red dots there, that's northwest London, near to where I was living a couple of years ago. The base price is slightly higher again, and the curve is slightly steeper. What's that curve? The straight line is slightly steeper again. So we get a pretty good relationship, it seems. And if we look at the purple dots, you see an even steeper line. So this is SW7, where our Russian oligarchs live. So this is a very expensive area, obviously. And one of the problems in an expensive area is there's a small turnover in property transactions. So we've only got a handful of data points here. But just based on the fact that we're pretty confident we get a linear relationship, so a straight line relationship, we could draw a line through those purple points and estimate the sale cost for, say, a 150 metre squared property with a fair degree of accuracy. And if you take that one step further, you take the prices for one particular area, And then you plot a surface, so taking latitude and longitude. So you know that in a neighborhood, you're likely to have cheaper areas and more expensive areas. So the blue areas, those are all the cheaper prices, and we can get really good estimates based on the meter squared and their exact location in that area. Those red areas, that's where areas of higher price properties, and we get clusters of those. And then in between, we've got no evidence of sale prices, but you can start to estimate some kind of curve, like a surface through there, and you can start to guess the exact price for exact streets and neighborhoods, just building on these data sets. Then we get on to classification. So here we ask the question, is this thing that I'm looking at spam or is it ham? So spam detection in the mailbox, well understood problem. And we will suffer from it and we will save time by not having to do manual spam classification. On Windows, when you run a program, often the malware detector pops up. This might be malware, you probably don't want to run this. Very useful to stop my mother installing malware if ever she was using a laptop. Is this row in my database a potential lead? Should I contact them now or should I contact them later? For text disambiguation, so with the example of the Apple phone earlier, is Apple being used in the context of Apple the company, or maybe Apple the music label, or Apple the food, or you Apple head, the Apple pejorative? So simple ways of classifying based on the context of the words around it. And then fraud classification, which is a massive area for banking and e-commerce, is the person putting a transaction through right now. Are they trying to defraud me so I lose money? You will find hundreds of examples online if you're interested in this area. It's one of the easiest ways to get into a relatively high-level machine learning problem with lots of tutorials and challenges online that can help teach you, and scikit-learn will be your main go-to tool there. And just to try and cement the idea just slightly in your mind. For classification problems, you give it training data. So the top row here, we give a set of visual examples. These will be binary vectors in the end when they go into the machine learning algorithm. You train it. This is what a 0 looks like. This is what a 1 looks like, and a 2 and a 3, and a set of numbers, thousands of examples. Thousands, maybe tens of thousands, possibly millions of examples. When it's learned, you can then go back to it and say, well, given this example here, what do you think it is? And hopefully it comes back and says that's a 4. And you go, great. So I can use that then to evaluate the quality of the classification algorithm, because I can pass in data it hasn't seen before and see how it predicts. And then I've got that gold standard. I know what it should say, and I can see what it says, and I can measure its quality. And when I'm satisfied that I've trained an appropriate algorithm that gives me the quality level that I need, I can then start to give it more unseen data, which will be the production system, and see how it does its classification. And there are loads more problems that we can solve, and I'm not going to go into them. I think Jen Sim has talked about this afternoon, so topic detection, identifying topics that exist in large volumes of text. You can do duplicate detection. That means that if I've got rows of data that are duplicated and they're all customers, I don't want to contact the same customer twice, so I can deduplicate it. Or I can look for duplicates, and then I can do things like check for copyright violation and plagiarism in essays. And you can go as far as speech recognition for call center automation. So using a machine to listen to a customer service operative talking to a customer on a microphone, and then using that to auto-populate the screens that the operative is using just to assist them in their flow of work. Now, when you get into this world, there's a huge amount of tooling. There's a crazy large amount of tooling. So I'll give you just a quick guide. Pandas is one of the main tools you will end up using. Pandas gives us essentially an Excel spreadsheet, but in the Python command line. So you can have columns of different types of data in a big sheet. So you have columns of date times, columns of strings, columns of integers, columns of text. Here you can see a visual representation of a pandas data frame inside the Spider development environment. And Spider's very nice, so we get a text editor, a data frame viewer, a variable viewer, and an interactive Python shell where you can drop your plots in, so everything is inside your development environment, and PyCharm adding similar features. So this gives us a rich development environment. Now, when you start learning data science, you'll come across IPython notebooks like these. So Here you have executable code in notebooks so that any graphical outputs are put in line with the code. This means that you can interact with that code and change the plots, which is great as a visual reference. It's perfect for teaching with, and it's great for exporting and mailing around to colleagues. Because it's the first thing you encounter when you're doing tutorials, it becomes natural to start tinkering with that code and then to think, hey, I'll just start developing my code in here. But the notebook is not a development environment. It's a horribly clunky development environment, so don't be seduced into thinking that. As soon as you want to start developing larger projects, look straight to an IDE. So what will your first project look like? So you're going to want to do a big iterative process, first of all. You're going to spend your time visualizing your data. And visualizing can be as simple as, this is the data wall when I started with the contract recruitment guys. So a year and a half ago, I just printed out everything that I could and stuck it on my wall so that people around me would ask questions and I could ask them, I could verify my assumptions about their data, and we could just visualize and pull out from their databases this huge pile of data that was otherwise opaque to them. Seaborn and Bokeh are great tools for that. You want to create milestones, so come up with milestones, discuss them with your colleagues. Check that these are high value and easily achieved milestones. Don't dive in too quickly, don't take on too large a project. Really, really apply the KISS principle, so keep it simple at the beginning. And use the scientific process. So think about the data that you've got. Ask yourself questions, come up with a hypothesis. So a hypothesis that's falsifiable, so you can learn something, whether it works or whether it fails. And then write the code, gather the data, and test the hypothesis, and then communicate the results back into your team. So you want to be learning all the time. If you ever do a piece of work where it might work and I might get something, but you won't learn anything out of it, then you are wasting your time. Please don't do that. Always work off the back of a hypothesis. And then you want to make sure that you are, and I'm going to say it again because this is very important, communicating your results. And the IPython notebook is very good at that. Or just those printouts on the wall, whatever. And that final point about engineering a solution in brackets, you will spend a portion of your time delivering an engineered solution, but the majority of your time is going to be spent developing up to that point. So think about that being your focus. It's an R&D driven process. So I've talked to a lot of my fellow data scientists in London over the last 4 or 5 months, asking for what are some of the biggest reasons why projects die. And this overwhelming message comes back. So it's because your data is bad. Almost certainly you have missing data, you haven't got enough data, you've gathered the wrong data, or you have data, you have lots of data, but it lies. It's got numbers out of bounds, it's got empty fields, it's got misentered data. There's all sorts of ways that your data can lie to you, and until you start to analyze it, you won't know. Then you start to build a predictor off of it, or you try to classify your customers or regress and predict some kind of outcome, and you find that your predictions and classifications are just garbage. They're either very low quality or they're clearly wrong, so that a manager looks at this and just goes, this is rubbish. Why did you even bother spending your time here? And it's almost certainly not the algorithm's fault, but the data's fault. So you need to be on top of high quality data. And because data storage is cheap, you should just log everything. That's the simple advice. So I don't care if you stick it in MySQL or Mongo or flat files or whatever. Just log everything. And Segment.io is a great site for logging your data, where it can then export it to third-party analysis tools. So if you've got nothing else, no other better choice to make, just use Segment.io and pass your data off down that way. And keep making data quality reports to understand the quality and the truthiness in your data. It has to be high quality. And remember that R&D is not an engineering process, so it's a related process, but it's not, we know what we're going to solve, here's how we're going to solve it, here's the delivered thing. Instead, it's here's what we want to achieve, here's how we might get there, and then I might go round and round and round in loops before I get to the point of knowing how to engineer a final solution. So it's very iterative, and failure is just as useful as success because we learn all the time. So now you've got to the point that you've got something working, you've demonstrated it, people agree this looks kind of sensible, you want to start thinking about deploying something useful. The first thing to do is internal deployment. So you can use scripts to just generate some internal reports, CSV files, database updates, whatever. Or the IPython notebook again. There's a nice feature in the IPython notebook with interactive graphing. So that interact function up there, you give it function f. In this case, function f just draws a graph. You give it some input range of argument it's allowed to take, and it automatically gives you a slider bar, one slider bar, many slider bars, and then you can pass this on to a colleague and they can start sliding the bars around or typing in text field, hitting buttons, and getting interactive reporting. So that's a nice way for a colleague who doesn't have your mindset about the data to start interacting with what you've got. And then you want to deploy a live system. Don't use the IPython notebook for this. When you expose it onto the web, it exposes your entire machine with no security at all onto the web. So that's a really stupid idea. Internally deploy it, that's fine, but don't share it on the web. Use something like Spire. So that exports matplotlib graphs, pandas data frames in a nice simple user interface, tens of lines of code to wrap up a very, very simple interface. Or my preferred choice is to develop microservices, and I use Flask for this. And then you can use things like Swagger for documentation and Docker to provide a containerized release service where you're not just dealing with releasing the code, but also the right versions of data. You have to match up the versions of data with your code, otherwise things get horribly out of sync. And that's what a Swagger documentation looks like. So someone like me who cannot write HTML and absolutely cannot write CSS, I can develop a relatively rich user interface and a couple of lines of Swagger in my Flask, so just a couple of lines of decorator. And then it's just like interacting with curl at the command line. I can copy in my JSON arguments that are encoded into that box, hit try it out. It calls the server and then shows the result that comes out. So this is a fabulous documentation tool. We use it inside Elevate because the main web dev is all done on the .NET stack and all the data science in the Python stack. So I'm just wrapping up now. Don't be seduced by big data. Generally, I'd say if you're not already using big data, just avoid the whole question. Do not be mistaken for the fact that you're missing something really important. You probably aren't. If you don't already have big data, you probably don't need it. A few thousand lines of high-quality data that encode the relationships that you're trying to uncover is almost certainly all that you need. If you are told that, hey, if we just employ this very large cluster and gather millions of lines of data over a couple of years will be amazing, you're probably lining yourself up for a very large project with very difficult ways of getting value out of it later on. And as a simple example, I've had people say to me, well, we've now got so much data, we need to have a cluster to exploit it because it's bigger than my laptop. And I just point to the fact that for a few dollars you can hire a 250 gigabyte RAM machine on EC2. So that's my laptop, but just 10 times bigger. And I can do everything on a single core maybe, on a very large laptop essentially in the cloud, without having to invest in a big cloud architecture and the engineer to support that. And there are plenty of options for scaling. I won't go into these now. If you want to talk about it, come and speak to me afterwards. So, here we are at the end. In the Python world, we've got a crazy good selection of tools. The main takeaway is that Python may not be the best language for data science. It may not be the best language for statistics. Maybe it's not the best language for web development, but it's good at all of these things. It's actually very good at all of these things. So rather than having multiple languages in mind and then different tool sets and different paradigms, we have one language, a generally shared paradigm, which lets us work across the board. You will encounter imposter syndrome, so I suffer from imposter syndrome. It's very easy when you're talking to someone who's a PhD in statistics and someone else who's been engineering all of their life. They're great at D3, they're great at interfacing with vast data systems, and they begin speaking, and you think, well, hang on a minute, what have I got to offer in this conversation? So data science couples at least two worlds, if not three or four. So don't be afraid of imposter syndrome. Accept that everyone, the more I talk about this, the more I realize that many of my fellow data scientists all agree that we suffer from this, and many people in programming in general admit that they suffer from imposter syndrome. So don't worry about that. Your business knowledge brings a lot of value to that conversation, and your engineering knowledge brings a lot of value there. The point about data science patterns, we are missing these in the industry. No one has yet written a book on patterns for successful ways to research data and deploy systems. So I'm trying to gather some of these patterns. If you've got successful deployments and you want to talk about it, I'd love to hear your stories. So come and tell me about those. And I obviously love talking about this, and I'd obviously love to get you all started on this journey. So come and talk to me. And the final point is, we are running our second conference, June 19th to 21 in London. Our call for proposals is open for 1 more week. I'd love you to come and speak. I'd love you to come and attend. So you'll find more about that on the blog. And just, yeah, come and ask me all about it. I think I'll finish there. Thank you very much. So I think I've got a few minutes for questions, yeah? So, do I have any questions, or have I answered everything you possibly had in mind already? Somebody must, there we go, we have a question. I have a question at the back. Do you want to shout out the question and I'll just repeat it?
So you said a couple of times that one of the problems that you have is that it's often bad data. So what's good data?
Good data doesn't exist. So good data is when you've got more data than you need to wrap up whatever relationship you're after. It's consistent. No lines are missing. No fields are missing. You never encounter I don't know, for pricing data, you've got 1,000 examples of the cost of something, and one of them is not a number, or a missing field in a CSV file, at which point a graphing tool blows up, and a machine learning tool blows up, because it needs to be consistent, everything of the same type, so it all floats. So good data is when they're all floats, bad data is when one line by itself might have one broken value. Typically it's 10%, 30%, or you're trying to join two tables of data together. It's not already in a MySQL database, so it hasn't got a primary key that you can join on. Maybe you've got a CSV file with customer details, maybe you've got a Mongo database with some product history, and then by eye, you're pretty sure you can join the things based on some text fields, then you have to encode that relationship in the machine, and it turns out that's really hard. And then you discover that even though by eye things look pretty similar, actually they're different products and different customers, and then so the data's lying to you based on the sort of parsimonious bit of data that you've got. It's not enough to really answer the question you're asking. So it's very common that you have these problems with data. It's very uncommon to have good, clean, consistent data. Is there another question?
Oh, I can ask a question, maybe. You talked about data and how to present data in the forms of graphs and a lot of other things which is related to data. But it all comes, it all depends on if your data is available or not. And I see that even today there are a lot of people who are reluctant to put the data online or put their information online. So do you, as a data scientist, take these things in consideration, or do you also work on how to make people put their data online if they want to, or are there any incentives for that? Or
when you say put their data online, whose data and what kind of data?
For example, you talked about automated recruitment, and for that you need data.
Right, so it turns out in that case, I didn't realise this, it's a dynamic in the industry. If you go to a website, so in the UK, monster.com is a huge recruitment site. If you go there and apply for a job, typically you've uploaded your CV into the site. The act of applying for the job sends an email to that company with your CV. So we're at the other end of that. Whenever you apply for a job that's in our system, the CV comes in automatically. And because job seekers are actively seeking a job, they've put their CV out there. So we haven't got to do extra work to get their CVs, they just flow automatically through to us. So in some business environments, that data flow is already there. You know, the CVs come in as PDF files and Word files. Maybe someone has made an all-graphic representation of their CV because they're a clever designer. It's awful trying to understand that. Maybe they've used a table with 2 columns and lined their dates up and their companies, and even Sovereign, the tool that I mentioned, doesn't understand a 2-column table, so it breaks everything. But most CVs are understandable. You can pull that data in. What's harder is when, in a large organisation, they've got all the data that they should be exposing, but it lives in different silos, and you have to go and get permission from different departments to pull that data around. And that's a political problem. Yeah, I'd love to solve that as a data scientist, but that's a human-level problem. That's not me and data and machines. One final question, or do we go to our break? I think there are no more questions at this. Oh, sorry. Go ahead.
So as someone working in this industry, do you think there's sort of a bubble here? Because like the media has been talking a lot about data science. And so yeah, do you think there's actually a huge need for data scientists? Or do you think that everyone is basically getting on board just because it's yet another trend in computer science?
Sure. So that's a very reasonable question. I'm in the data science world and I run a data science group, so obviously it's not a bubble and it's a true trend and it's all going to be amazing. I've been doing this 15 years. 3 years ago, there wasn't a data science bubble. I left the country to go and join a startup accelerator, but 3.5 years ago now. I'd asked at an event in London, would anyone like to do a data science event? Kind of 30 hands out of 500 went up. And I thought, oh man, no one really cares about this. I'll just keep working in my little niche. As I'm flying out of the country to go to South America for 6 months, a data science group in London emerged. And by the time I checked in a few weeks later, it was at 1,000 members. So out of nowhere, this thing grew up. So it certainly has bubble dynamics. Many companies have data. Many managers, in my experience, do not understand data. They're not numerate. So there's not a drive from the top to exploit data, but many people are realizing that they have data and it has value, and if only we could do something with it, we could generate more business value. So there's, I think, a bottom-up drive and a top-down desire to do something with this data. No one really knows how to bring it all together. It only works for some companies. It only works for teams that are sufficiently motivated. It only works in an agile enough environment where you can try experiments and discover that things don't work and things do work and knit them together. So I think it is a genuine trend. I don't think it's not the next big thing that's going to wipe everything out. It's just another way to use your data. The same as displaying it on the web is another way to use your data. So I don't want to undersell my industry, but it's just another thing. It's going to be significant. It's not going to wipe everything else out.
So I guess that is it. I don't remember, have we already uploaded you?
I think we did, but thank you.